Thank you very much for this opportunity to present part of my research. This is about the in vitro study of the deployment of 3D printed stent in the disease artery with the middle arterial plaque. When you hear about the plaque, means the cardiovascular disease, which is the cardiovascular disease caused almost 30% of the worldwide death and even can lead to the disability. Also, the peripheral artery disease, which is known as a PAD, is one of the cardiovascular disease, which often occur because of the stenosis of the artery and the decrease or absence of the blood flow. PAD results from the what's so-called plaque and leads to the vessel stenosis and limit of the blood flow in the artery in the arm or the leg. If this remained untreated, that result the lack of oxygen downstream to the tissue, leading to the ulceration or gangrene. Ultimately, lip amputation may require. In this case, there is a solution for that, which is the stent implant called the peripheral stent, which hold open the artery to remain the blood flow go through. However, this type of stent, which called the polymer stent, have some limitation. One of them is the poor mechanical property, which therefore are likely to prevent mechanical recoil after the deployment. Alternatively, other type of stent is growing up with the metal stent using the AM via selected laser melting. However, this is not well explored from the cardiovascular field. Recent studies have proven that the AM emerges an innovative technology to fabricate medical stents used to treat blocked artery. Also, several studies demonstrate that the plaque composition affects directly with the stent. Although this has been happened, there is a little known about the effect of the plaque composition on the arterial wave and in the arterial stretching and stent. Therefore, the aim of this study is to investigate the effect of the plaque composition on the deployment performance of the stent with the very design. In this study, we firstly prepare the artificial plaque with the 98% lipid, which is mostly lipid, with no calcium existed, and the fibrous cap is 0.1 millimeter. For this, to fabricate this lipid plaque, we have used the gelatin from the bovine skin and the collagen from the human to fabricate the fibrous cap firstly. And then, as it is mostly lipid, so we have used the soybean oil to represent the lipid core. Collagen and gelatin, we mix it together with the diluted water to fabricate the fibrous cap. This mixed fluid was poured in the mold, which takes the shape of the fibrous cap with its thickness, and then lifted for the 24 hours to ensure its thickness degree. Finally, the artificial lipid plaque was injected in the bottom of the fibrous cap using small medical syringe. The plaque dimensions are 25 millimeter length, 4.5 millimeter wide, and 55% protected. This is the fibrous cap from the bottom and the top, and this is the whole plaque that I have been using in the experiment. Then when we prepare the plaque, we have done the mechanical property using the amplified compression test to evaluate the mechanical property of the lipid plaque. We use the Miller method of testing very soft biological tissue, and for this method we have used the coarse sandpaper to attach on machine plates to prevent the no slip pound condition. This is the lipid. This one is the lipid plaque, and this is how the coarse paper attach one of the plates. So the sample dimensions is 30 millimeter diameter, very small, and 10 millimeter wide. Then the stent design, it was made by 316 instant steel and fabricated by the AM technology. Two types of stents, the V shape, which is printed one, and the commercial one, were implemented in the experiment. This is the commercial one, and this one is the V shape. This is how to record the change of diameter, and this is the plaque after the fully expand of the stent. This is the experiment setup, stent, crystal to measure the change of diameter, plaque, and the balloon inflation device to exert a pressure. This is the stent with the balloon, and here is the stent with the plaque and the change of the crystal to monitor the change of diameter. Here's how to record the change of the diameter, the pressure, and the inflation. This is when it has been finished. This is how to record the whole process.
Good time.
So firstly we get the result from the mechanical property. This we have done the loading and unloading compression test. As you can see, the highest stress is approximately 0.16, which is close to the human lipid plaque. And this is the result of the printed stent. As you can see here, the time, pressure, and diameter, we try to collect the diameter and the pressure at the same time. As you can see here, there is a strong positive correlation between the diameter, change of diameter, and the pressure. Also, for the commercial stent, it's the same as well. Yeah. And also the same result with the commercial stent. Conclusion, then the results show the mechanical property of the artificial plaque was very similar to the real lipid plaque that observed from the clinical study. It means that the artificial plaque could be used or could open a door for the cardiovascular research, especially for the biomedical engineering, to apply this type of plaque in their research. Also, it was observed that there is a linear relationship between the pressure and arterial wall movement with the lipid plaque in both printed one and the commercial stents. Means that we could use the printed one in the cardiovascular field. And thank you for your listening. Any questions?
Thank you very much. So now we have the time for your questions. Let me start. So these are, yeah, I know about these studies, but still. So generally, you started separately stent, you started separately the plaque. So what are the next directions of your research? Are you going to change the position of the plaque, the size of the plaque?
Yes. The second stage, which I'm already doing now, is to use different types of plaque. So now it's a lipid one. Before I come here, last week I've done the calcium plaque, with the half of calcium, half of lipid. And we use the other type of stent, the U stent, and the zigzag stent. So this is maybe when I finish the conference, I will apply there in the lab. And also the position of the plaque. So because that's only for one side now, so next is going to be for both sides. And if there is two plaques, how we can treat with it. So that's the next stage for my station.
I'm curious, have you already measured the calcified one? How much stiffer it is compared with to the liquid one?
Well, the one that I have done before, if you remember, that it's very, very, very tough.
Yeah.
The reason why, because I have used a collision with the calcium, which gave me a result with the high stiffness. Now I'm doing the just only calcium, which is also close to the human body. There is, because I've done 3 times, so I will try to do 10 times to see the statistical result. Is it nearly to the human body? Okay.
Please.
Thank you. Thank you for your presentation. I'm Ramiro from Madrid, and I wanted to ask you, do you have any insights on the change in behavior with the degradation of the plaque in time?
At the moment, I haven't done that yet, to be honest. But thank you for this. This point might be done for my future research and plan. Yes, I haven't put this one in my consideration. To be honest, my concentration is how the effect of the plaque composition, how it affects to the stent. So for the next stage, I may put this in my consideration.
Yeah. So just to add to this clearly, because the plaque is being reproduced inside the body, so that's why it's just, we can't speak about the deterioration in the sense how, for instance, we are speaking about deterioration of the, so just stents or anything what we are putting in. Clearly there can be the ways to just due to the medication and what's not. But this is, yeah, so just, this is generally an interesting point. Okay? Good, then thank you once more. Let me, my understanding that not all of us